presentation about a blue-gray solution for mitigation coastal erosion on permafrost coastlines. And that is a case study in Longyearbyen, Svalbard, Norway. This work is developed by me and Ingebrigt Uglim, colleague of mine from NINA, Norwegian Institute for Nature Research. A quite similar presentation was given last autumn on cold COP, but there are some developments since then. But overall, that's the content approximately is the same. And I'll try also to keep track on time. This work is a part of a large EU project that is called ClimaRest, that stands for Coastal Climate Resilience and Marine Restoration Tools for Arctic Atlantic Basin, a 4-year project with many partners across Europe. It is an interdisciplinary project, and it has demo sites that are spread from Madeira in Portugal in south, further in a site in Vigo in Spain, in Brest in France, in Ireland, and also in Svalbard in Norway. Then straight to the point, this work takes place in Svalbard, that is located about 1,000 kilometers from Norwegian mainland up north. And there we are dealing with a coastline on a landfill. On the picture in left lower corner, you can see positions of coastlines, and those are positions of landfill. So it is artificial material. The whole site is the coastal stretch, which is locked into 2 piers, one called tourist quay and another the old quay. And the whole stretch is 340 meters long, and it erodes. And we can see a brief video now with the site. And we were lucky enough to get in contact with local municipality when we got this project, and to find a practical case for the research we do. Then I think we proceed further. This site, and Svalbard in general, characterized by several distinct futures, if may say, this one may say. Well, first of all, Svalbard is a place perhaps with one of the fastest, if not the fastest, warming rates in the globe. And recently it was discovered that particular locations, they're warming up to 7 times faster than global warming. The coastal type here is a sandy beach, which is like covering or overlying of cohesive shore. One may see this on the right lower corner of the screen, the soil composition. It is under erosion. It erodes. We presume that it's isolated from longshore sediment transport from other parts of the coastal line, because it's linked between 2 piers. Not that big waves, about 1.3 meter significant wave height. There is landfast ice, sometimes drift ice, relatively shallow bathymetry. Native soil, which is under the landfill, is extremely weak. The steel piles in this area, they even don't have to be driven. In some cases, it was reported, they just slowly slide down in the ground. So it's very weak. Some of this soil is polluted. Pollution is not that high at average levels, but it's there. And last but not least, this area needs to serve the public needs. And again, it's a problem. There is a problem that it erodes, and there is a road nearby. You can see it on the drone picture above. And also, there is a need to use it for pedestrians. Local commune, they made a vision on this area where they want to make a promenade, and they got an idea to use timber to make this promenade, and this timber was delivered from decommissioned Svea mines in Svalbard. Svea is a mining settlement, former mining settlement. Now it's fully decommissioned and cleaned up, but it had a lot of timber in those mines, and they took a decision and shipped several containers of this timber in Longyearbyen, and with a view to make this structure. So that was one of departure points for us, and we took this further, as you will see further in this presentation. But this project is about marine restoration with focus on ecosystems. One may ask why we should do this. Well, there are global, so to speak, frameworks and legislation that require us to do so, and there are also goals to restore 30% of marine habitats now by 2050. We began this work with a view that handling of coastal erosion in this stretch, it needs to be done from the standpoints of sustainability, with focus on environment, meaning conserving biodiversity in our case, also with minimal environmental footprint of materials and operations that we use. But also, inevitably, we have to handle the social aspect to maintain the needs of citizens in Longyearbyen, and economics. It needs to be affordable. It is not a secret that economics is quite harsh in many Arctic conditions. So the Arctic itself, it's hard to find money. So we have an ultimate goal to make something simple, affordable, that can be done with the local labor, probably even volunteers. The guiding documents for us the following. We follow the general guidelines of Society of Ecological Restoration, SER. However, the guidelines at the moment, they don't have the protocol for marine restoration, coastal marine restoration in general, and for the Arctic in particular. So perhaps something what we do can strengthen somehow those guidelines. And in ClimaRest we have 4 other sites which are working towards this in temperate climate. Then there is a very useful, excellent document, SAGE, which has a subcategory need living shorelines. Permafrost coastlines are not included there, but we found this document extremely useful. There are also some other documents available which we didn't use. Also, from the very beginning, we wanted to use co-creation approach, which can be seen in guidelines of SER and also in SAGE. In practical terms, we follow normal practice Eurocode standards when we calculate geotechnical stability and etc. Our very brief reflection about how we used SAGE, which stands for Systems Approach for Geomorphologic Engineering. It advocates several approaches how to mitigate coastal risk. risks, and some of them they are natural or nature-based. And what we find especially appealing that SAGE promotes hybrid engineering that includes both natural or green solutions and green infrastructure. And for us, we see this very closely aligns with practical realism, what we also acknowledge, and we see need for this when you start working with real problems on the ground, so to speak. Then, as a part of SAGE and living shorelines, there are outlined approaches how to do this in temperate climate. And then they advocate that by doing shorelines, again, both living shorelines, both gray infrastructure and softer solutions used. And as a part of those, also co-creation can be seen as a part of this. Again, living shorelines, they do not cover permafrost coastlines at the moment. There could be different definitions how to define nature-based solutions. We stick for one which says they're inspired or supported by nature. There are more details about this. Also, it's important to say that nature can be restored with other solutions that do not strictly align with NBS, and also using NBS is not necessary restoration. Can be not necessary restoration. Then coming back to guidelines of SER, we follow the main line of these guidelines, because specific guidelines for coastal marine installation, again, they are virtually not existing. So we follow the main recommendations. And then as in our case, we have a landfill. If you would want to make ecological restoration in this part, then landfill would need to be removed together with road and several industrial buildings and another road to airport. So no need to say that that's not possible. In this case, one should or could do in this situation restoration on the level of remediation and rehabilitation, meaning that we will create a system that is typical for this region, and this system will provide ecological services. However, this ecological system will not function like as it would be entirely, so to speak. One may see on the next slides the main principle of SER, which we use as much as we able to. And then when it comes to restoration, there are standard steps in this procedure, starting from planning, stakeholder engagement, in our case speaking with commune, baseline inventory, especially when it comes to biodiversity, surveying reference habitats, creating a plan, a blueprint, and implementing it, monitoring how it works, and then giving advices how to use this further. It's very important to mention that as long as we are dealing with restoration, we need to validate what we do. And there are two principles or key points that need to be obeyed here. That we need to compare baseline with reference systems, and we need to evaluate what was done from environmental, societal, and economic levels. Having said this, there are multiple parameters that can be used if one have data before and after. But again, collecting data before and after and collecting data from reference sites is crucial, as well as using this data to evaluate the effects. Again, we deal in our project with remediation and rehabilitation. So what we do, we replace an artificial landform, which is anthropogenic material stored on the shoreline, so to speak, with a replica of natural landform. In our case, we will see it a bit further. It will be rocky coast, and that includes intertidal pools. And we do this because restoration of original habitat is not possible. An original habitat would be rocky shore, which now can be seen approximately, I would say, to 300 meters from this line. On this slide, we can see our reference sites. So we have 3 reference sites in Adventfjord, each of them in about 3 to 5 kilometers from our main site, marked in red. And we have also a reference site just by our prototype. And the reference sites that we use is one if you start from left to the right, Yurtham, a cohesive shore overlaid by sand veneer, sand layer. Then in Vestpunten we have gravelly, even boulder beach, which rests on bedrock. And then in Ravnes site we have rocky shore. Then now looking into the site itself, this site, again, it is like a gravelly beach which rests on a cohesive platform underneath. And then we have here also reference site. In the red frame you can see area where we plan to build prototype, and in the green area this area that we will compare with what we are doing in the red area. And obviously we envision that what we do should be situation should be improved in this red frame compared to the green frame. Again, it's not possible to restore natural conditions in this site because of the reasons just mentioned. We need to consider the human needs in this area, and then restoration here must be in compromise between urban development, conservation of biodiversity, and practical realism. For the ecological part, we use here, or we try to establish blue spaces, an analogy to green spaces in urban environments. And those blue spaces, in our case, it's an intertidal pool. And this was done in many coastal projects across at least Europe. They usually reproduced in smaller sizes, so they can be not bigger than 1 meter in diameter, those pools. But that is an example of pool here in Trondheim. Then in practically what we did mapping of topography, bathymetry, ecological situation, ecological conditions. After this, we began to develop a prototype, and then now we are waiting for permits in order to implement, and then hopefully it will be validated later on. Then that is again a summary why this is a summary which guides us to the solution, what we do. And again, we try to replicate coastal types that can be found in the area. We deliver two things here. We deliver vision for handling coastal erosion on the whole coastal stretch, which is in question, again, that is 340 meters long. And then we will replicate part of it, a representative element of this stretch. And that is what we suggest, that on this stretch we suggest following the idea of Port of Longyearbyen to create a revetment made from timber, and then this revetment will have in it several intertidal pools, and then there will be floating piers connected to revetment, because port needs parking space for small boats. Further, if we move to the right from revetment, we envision there could be boulder beach, and this is one landform that many Norwegians like. One can see boulder beach around Trondheim and other places. They exist in Svalbard, and that is something what people love. But by establishing this timber revetment, we will block sediment transport which comes from this eroding artificial coast, which we think provides sediment to the last part on this coastal stretch, to a local beach where locals like to go bathing. So we envisioned that we need to put a pile of sand that is called sand motor. The visionary idea developed was suggested and tested and developed to some degree in the Netherlands about 15 years ago, a decade ago. So that's the vision. And then here in these intertidal pools, the intertidal pools and the boulder beach and the sand motor, they should comprise 30% of the length of the coastal stretch, and then this will be in the line what the restoration conventions and legislation wants. We present that as a vision, but that was presented to Port of Longyearbyen, and then they were quite positive to hear that. So we will see what happens in the future. And as a part of this, in blue frame, you can see the prototype that we plan to build. And this prototype will be composed of one intertidal pool and a section of timber revetment that we can see here. The revetments, they will be built, as I mentioned, from timber from Svea, and specific part of it that this timber members, they're quite short, only 2.2 meters long. Then for the whole stretch, again, we suggest a blue-gray solution, revetment from reused timber from Svea, intertidal parks, boulder beach, and sand motor to support the nearby beach. And intertidal parks made from reused rock also that was delivered, some of it from Svea, some of it from mainland Norway. Will be used for conservation biodiversity there. For recreation, there will be a wall for boating, section of promenade, possibly education component with underwater camera, and outdoor playground. As for the prototype, what we plan to build itself, which we will see in more detail in the next slides, we performed design of it. One may call it feasibility study, but it's designed according to Eurocode, designed internally in Sintef, and then the design was checked by external consultant. design replies to stability, geotechnical stability, wave loads, ice loads, and also it includes cover protection in front of the structure, what we will see further. There are a number of considerations how to handle timber here, and also permafrost, despite it present in terrestrial part, it doesn't seem to be a problem in the sea. So there is no submarine permafrost, and neither there is a permafrost in intertidal flat. And one may see a sketch of permafrost outline here. And we know that permafrost in coastal zone in Svalbard, and by coastal zone, where here we mean the area spreading from high tide to inwards for 100 meters. Permafrost usually is warm there, about -1, -2 degrees, and saline. Quite weak permafrost. I'll skip some details about the design here, but again, with intertidal park, we count that water will go in and out, and intertidal park, intertidal pool will be sealed from the bottom. We began this work with environmental survey. First, we collected data on biodiversity in the area from the literature, and then we collected sent samples from reference sites and from our site with a view to make something called eDNA, environmental DNA analysis. And that is analysis that allows to see the principal families of species that are living in the area. And the idea is that we collect eDNA samples now, and then we do it again after the structure is composed, and then we see changes in vertebrates and microbe communities. So it's quite like a small size of creatures, but also birds, they can live in intertidal pool. Then those are slides from collecting eDNA samples. Again, they were collected by the site, at the site, at the reference site close to it, and then also in our reference sites further. And surprisingly, there is quite some life, as you may see on this video, on those coastlines. And we flipped rocks a couple years ago within Gibrit there, and we didn't see any of those small, I would call them creatures because I don't know the proper name. Looks like a small krill, but in 2024, last year, they were there, and a lot of birds. Then again, the same things were done at reference sites. Skip that video, and then also Yurtham, we did it there as well. Couple words, I won't go in detail about timber, but timber may be considered quite interesting material to be used in coastal protection. It has both advantages and drawbacks. Yet it's not easy to use timber due to also legal matters. One must have a timber of very high quality, something called class number 5 for marine works, and there is also marine parasites that are eating timber. But in the Arctic, historically, timber was used in many occasions because there is no such marine borers in the Arctic. But if one use recycled hardwood or recycled timber, then that seems to be very ecologically friendly and extremely, like maybe ultra ecological material, because it's by default timber is a good material, and then if it's used again, there are a lot of benefits. However, it may rot, and then this needs to be taken into account. We know that in Svalbard, a timber pile on the house rots in about 30 years. in terrestrial conditions. But in Barentsburg, in a Russian settlement close to Longyearbyen, timber was used for coastal protection and was successfully used. There were some issues, but steel structures are there. It's not that easy to repair those structures. I'll tell a little bit more about it later, how we tackle it. But the overall experience was pretty positive. Again, marine borers, it seems that they didn't come to Svalbard yet. So then, speaking about replication, that's something to look at in other parts in the Arctic. That is rock rubble or stone rubble, and 150 cubic meters were donated to us from the municipality for this work. And then we began this. Well, we created a vision what we plan to do that we just looked at in the previous slides. And then we made a co-creation workshop, and well, yes, we arrived on this workshop already with our vision, so perhaps it's not 100% co-creation, but it had the two parts. First, we presented the vision, what we plan to do, and then we asked participants in Longyearbyen about challenges, what they see in this area, and the solutions, how they see them. And then we take these learnings to tune what we do. So then the questions we asked, how do you see this area from your perspective? And we were lucky enough that about 25 people came up, and they were old-timers, like people who live, maybe old-timer is not the right term, but there is a term, because in Svalbard people come and go quite frequently, but about 300 real locals, they live there more than 10 years. So then they were like real locals who live there several years. They were people from municipality, couple politicians, they were people from industry, students, very nice representative group of different groups. And then we asked them what are the issues in this area, and then out of those 25 answers, and it was allowed to put as many answers as you might want, we found that there are human needs that people mostly worried about the human needs in this area, even though functionality and durability and erosion control, even area conflict was acknowledged. And then the solutions, among the solutions, we see that the recreation, that whatever would be built there, it needs to serve recreation needs. Someone wanted to have their promenade, someone wanted to have the part of wild beach. Others, we know that port wants to use at least part of it as a small harbor marina, but recreation is sticking out. And also one of great reflections from this workshop, what we saw, that we saw different groups of people with different interests, and then but they were talking to each other in physical environment, and it felt, at least both of us, Ingibrit Uglin and myself, that at some point we all realize that whatever will be built there, it will not be ideal for anyone, but it may be acceptable for everyone. And that gave kind of, in the end, quite a comfort that we were leaving this place again thinking something will be, if it will be done, something will be done that will be mostly acceptable by all, but not ideal for anyone, for sure. So then the last slides, I don't have many more slides to go. That is the final outline of what we plan to do. That is what we submitting now for expertise at the local government, central authorities to be approved. So it's a section which we will see in more detail in the next slides. It's a timber caisson made from timber, then it's a rock revertment, and then intertidal pool. And then in black, a floating a pier can be connected to this, and then it can be used for mooring a small boat. And then we envision to put some benches and light, to put a wind wall that people can come and enjoy it. And we really saw in the workshops that people need something, some nice urban environments to come and have a walk and maybe to stop by and to look at the mountains from this viewpoint, maybe exercise. That is a cross section of this structure. If one can see it, you can see here, it goes through the timber caisson. We intentionally put hedge below this as we designed layers with different rock sizes beneath this, and we are not sure that it's gonna work yet. And then we also don't want to release this consultancy information out of in the internet, as consultancy needs to be done by professionals. So now it's not shown here because in this part would need to be designed to specific soil conditions. But one can see here timber caisson, and then we have soil anchor, and then also anchor plate made from timber as well. And in front of it, it's protected by rock rubble against scour. And that is a cross section across intertidal pool. So water will go in and out during tides here. And that is a cross section along this prototype. So we're ending up now almost a 30-meter long structure. And yes, again, we can see here intertidal pool, and then 3 caissons. They're about 4 meters tall. And those caissons, they look like that if you look closer to them. So it's 3 caissons, each 2 by 2 meters. They connected to friction plate. And I mentioned before that timber of road can be dangerous. So we in our design, we make design so that the upper part of the caisson can be disconnected. We think it should be easily disconnected in about 20 years, for example, and replaced with a new part. And in this case, at least theoretically, we hope to counteract the road. Also, the construction made in the way that the front part of caissons, it can be exchanged, and that is not possible in the constructions what we saw in Barentsburg. Those are not repairable in this way. Upscaling, we hope that this can be used in this coastal stretch to do something more about it, and also perhaps in other places in the Arctic. And when it comes to, but there is definitely a room for deeper design, and this may be called deep scaling. So then we look forward in the future to upscale and deep scale it both locally and across the Arctic. And that is local demands for coastal erosion and Longyearbyen. So one may see that in general, everything erodes in Longyearbyen. And then so it erodes in Arctic communities, as all of us as all of us know. That's essentially it. There are contact information and some references in this slide. And we will share PDF of this presentation as well.
Awesome. Thank you, Anatoly. That was really good. So we have, about 13 minutes for questions. So does anyone have any questions?